Welcome, everyone. Thank you for joining us for this afternoon session. This is for accepted paper talks that were submitted and reviewed by a committee of over 30 people to try to put together this program. Unfortunately, one of our speakers wasn't able to make it today, so I have the honor of giving the first talk of the session, so please bear with me. But this is about App Inventor and the work that we do. So App Inventor is one of the 3 pillars of the MIT RAISE project. And we are a system where you can go and you can build your own mobile phone apps on the web. And there are a number of curricula that have been developed around the world, some within the US, some in other places, to allow students to learn about computer science and solving problems through mobile apps. And a lot of this work really is inspired by Seymour Papert, who was a professor here at MIT. And over 40 years ago, he was talking about how important it was for kids to play with computers and for them to experiment and to learn about this technology, which at the time, computers were huge, right? They took up, a massive amount of space, probably as big as this room. Yet it was important to show to these young individuals the power that came from having access to this technology. As we're thinking about the transition into the AI era, we believe at MIT App Inventor that this is a really important thing for us to be exploring as well. One of our colleagues, former colleague of ours, who is now a professor at the University of Illinois Urbana-Champaign, Mike Tissenbaum, he coined this idea of computational action while working with us. And this idea, not just that you think about computing and how computers work, but with young people, you can enable them to engage in the world in a completely different and hands-on way. And so we call this computational action because it's not just about thinking and solving problems with a computer and living out on the web, but actually putting that into practice in the real world. And now App Inventor, of course, is now a worldwide phenomenon because of this. And we have users all over the world. In the United States, we have about 1.5 million users. And you can see the top 5 there, representation from Asia, Latin America, and so forth. And just recently, as of last Friday, we passed 120 million projects that people have built with App Inventor, which is just a really great success for us to see over the last 15 years how many different ways people have solved problems that they've encountered in their world. So overall, we've had about 24 million users, 120 million projects, as I just mentioned, and about 1/3 of those users has actually gone ahead and compiled their application to run it on their own phone, right? So it's not just a matter of, oh, I built something on the web, but that I took it out into the world and did something interesting with it. And we think that's a really fantastic thing to see. And now we've been working on a number of different updates. So what I'm about to show you is some new material that our team has been working on. If you have the opportunity after this session at 3:30, there'll be some workshops and demo sessions. Workshops today, demo sessions tomorrow, where you can try out some of this stuff. So the first is what we call our Mobile Data Science Toolkit. And the idea behind the Mobile Data Science Toolkit is that you can go and you can collect real-world data, and you can use that to inform yourself about what's going on in your community and in your environment. So here's an example of some work that was done. Just recently, one of our colleagues went out to Stanford in East Palo Alto, California, and they went and they built a bunch of sensor kits, and they put them up in trees to measure a bunch of stuff like air quality and so forth. You can see some of the electronic work that's being done there, so it's very hands-on. They go out and they deploy this stuff, and then they build an App Inventor app where they do the data collection, and they get to see how the data is changing over the course of a day. This is another example where we start with a microbit, we build on top of it a bunch of sensing equipment, and then we are able to go and put that information into a model, and then you can use that to make predictions about how the data kind of inform what's going on in the environment. And then we also tie it into things like a chat-based model, right? So in the third image on the right there, we have a generative AI-based explanation for the data observations that the students are making. And then they can compare and contrast their own conclusions with the ones that the AI models are making. So Here are some resources about this. So you can get all this curriculum online. As I said, there's a workshop. The 3:30 workshops will go into a little bit more depth where you can actually do some of this hands-on, but you can scan the QR code and the slides will be available online later if you want to have access to all of the curriculum materials as a teacher. So the next project that we've been working on we call the Historical Advisor. And this is actually inspired by a talk that Steve Jobs gave back in the 80s about how cool it would be if you could have someone like Socrates as an actual advisor to you, or Aristotle as an advisor to you. And of course, we talk about in teaching a lot the Socratic method of teaching. And so our ed team lead, Slim Tazel, decided, wouldn't it be cool if you could have all these different personalities? And you could ask them philosophical questions or mathematical questions. And so he selected a wide range of different individuals. And in the code, you actually, let me show you that since we have it. This is the entire code for this app in App Inventor. It fits entirely on a single screen. And the idea is that you can go and a lot of it is mostly just about handling the images. But you can go and you can actually have a conversation using a chatbot to try to imagine what would this person have said if you were asking these types of questions. And of course, one of the cool things about this is kids then take it and they add their own kind of heroes to it, right? Like someone they admire, some icon of theirs, they put that person in too, and so they can really make it their own. And maybe they use it as a study guide or do something else with it, but they really get some ownership over how they interact with the AI. So if you're interested, we have a number of other artificial intelligence tools. I'm not going to talk about them today because it would be a full hour-long talk. But there are a number of tools around like convolutional neural networks, generative AI, Markov models. So if you are interested in learning more about doing AI with App Inventor, I definitely encourage you to check out our tutorials. So that's sort of the curriculum updates that App Inventor is focused on this year. And now I want to talk about the technical updates. So in my role as the lead developer for App Inventor, my job is to really kind of think about what are the next things we should be developing to make App Inventor a great tool for teachers to be able to use in their classrooms. So the first thing that we've been exploring, and we're hoping to get this out at least as an alpha demo that people can start trying and give us feedback on, is web testing. So we hear a lot from teachers that either testing with a phone, for example, a number of schools are now banning the use of phones in classrooms. So how do you test your mobile app if you don't have a mobile phone? Well, we do have an emulator package, but it's a very heavyweight piece of software, and often students can't install software on their laptops. So we are developing a web-based version where effectively you can try out your app, and it behaves just like it would on your phone, but it's all done in the browser, and so now you get the experience even without having the equipment to do so. And the other nice thing about this is it can run offline, potentially, which means we can go into communities where they don't have internet access to be able to use it. The second is we have an App Inventor Foundation that is building a teacher portal. And already they have done a number of workshops with this teacher portal. If you're interested in early access to try it out, you can join the Education Collaborative that's available there. And the idea is it is a portal where there's no PII collected on students. So there's GDPR compliance, all these other things that we have to worry about. So we don't collect any data on students. And then you can do things like manage your classes, manage assignments, do grading, and then manage all of your AI API keys securely and have that available to manage your classrooms. And then the last thing, which we demoed a little bit last year and we've been continuing to improve, is called Aptly. So Aptly is a version of App Inventor where it's backed by a large language model. So you can give it instructions on how to build your application, and then it goes ahead and tries to help you out. So this is a classic example of an App Inventor app that we do with students. They love it because it makes noise. So you get a picture of a cat, and then when you tap on the cat, you want to make it meow. We give you the image, we give you the audio file, and then these are the blocks. And so we've trained the model so that we can give it this instruction, and it can come up with the blocks needed to make a sound play when you click on a button. And then you could start building more complicated things, right? So it's incrementally updated based on your instructions. So I can say like, oh, make a label below the cat that says pet me, and it has these properties. And then I can do something like say, make the label larger. Now, this is where the large language model starts to have some challenges, right? So when I said make the label larger, my intuition and what I was expecting was that the text would be larger, right? But as you can see, all it did was make the rectangle bigger. But then, so I have to refine my query, right? So now I can say, well, make the font size bigger, and then the model can do the right thing. And so you can start to have conversations with the students, like, why do you think the machine did that? Like, why did it do this and not what you expected, right? And this is a great opportunity for you, them to really understand that the machines are still not quite aware of what the human intuition is around what you're asking it to do. And so it's a great exploration of what machines can do and can't do with these new tools. And then continuing on this theme of trying to be able to do stuff offline, we just had a student this last semester who finished a master's thesis on trying to make it so that Aptly could run on a mobile device. And so this is a picture of a version of our companion app for iPhone on the left with a new button that allows you to speak your app idea to the phone, and then it goes ahead and tries to create it, and then gives you an example of what it could make on the right-hand side. And now this can all run on, it has to still be a fairly beefy iPhone right now. We're hoping to make this even more effective so that you could deploy it in remote communities with lower cost, cheaper iPhones and Android phones. But the idea is that you can do all of this large language model stuff right on the phone. You don't need internet access, but you can deploy real world applications just by talking and saying, hey, I need an app to do this. So we use Llama 3.2 3 billion parameter model. Takes about 2 gigabytes of RAM. So you still need, that's why I was saying you need a higher end phone, phone with a less RAM, it won't run. But we're continuing to refine this. We have a student right now actually who's working on using the 1 billion parameter version of Llama 3.2 so that you can also do the chat capabilities. And so that will be hopefully a new feature of App Inventor going forward. So takeaways, please. I'd love for you all to take a look at our new curriculum. Our education team is over in W20 right now doing workshops. I'm sure they'd love your feedback and comments on the work that they've been doing. I'm always open to learning more what your future requests are and figuring out how we work that into our development schedule. And then we have a number of demos tomorrow, stuff on robotics, some augmented reality. We have the data science work that I talked about earlier, and then you can play around with Aptly as well and try to make apps with it. So I will cede the floor at this point and try to get us back on schedule. So these are the talks for the session. Very briefly, you'll see there's a number of things around large language models, robotics, and teaching in K-12 level classrooms. So I would, at this point, like to invite Julia up. Yeah, there you are. To give her talk. And Julia is a PhD student, yes, at the University of California, Santa Cruz.